I'm doing a bit of testing on the heat sinks from an old G5 Power Mac. It was a dual processor, so I have two of the heat sinks, but only two. Now if I can get 300 watts of heat dissipation out of each of these, I think I'll go with a couple of the big 240 amp MOSFETs to make the electronic load. Even if the transistors are more money per watt, not having to buy any heat sinks will easily make it the cheaper route. If I can get some kind of approximate thermal resistance of the heatsink, maybe I can tell if it will do the job. Calculating the thermal resistance of a heatsink is really complex. Throw in forced air and it gets more so. Add heat pipes and I would expect it moves into the area of out-of-this-world complexity. And I don't have the knowledge to do it or the time to learn. So the idea is, throw some controlled heat at the heatsink and take some temperature measurements. See what pops up. Something like this, the thermal resistance junction to case is from the data sheet for the IXTH80N075L2 MOSFET. The thermal resistance for the case to heatsink for a TO247 package with just thermal grease seems to be about 0.2 degrees centigrade a watt. I can't measure the case temperature as there's no exposed metal on the TO247 case. As for the heatsink temperature, I just tried to find the hottest spot close to where the MOSFET is mounted. The first test is at 60 watts. After the temperature stabilizes, it gets to about 7.8 degrees centigrade difference from ambient to heatsink. So if I take 7.8 degrees and divide by 60 watts, I get 0.13 degrees centigrade a watt thermal resistance. Now at 90 watts, the temperature difference is, let's say, 10.6 degrees centigrade. I get about 0.118 degrees centigrade a watt resistance. Going to 120 watts, we're at a temperature difference of 13.5 degrees centigrade. So that's about 0.113 degrees centigrade a watt resistance. And finally at 150 watts. I'll call it 16 degrees, so that gives a thermal resistance of about 0.107. So it seems the thermal resistance of the heatsink goes down as the temperature on it goes up. And that makes sense when you think about the air flowing over the fins. The hotter the fins, the more heat the air can absorb. But what's this going to do for me at 300 watts on one of the big MOSFETs? If I use the thermal resistance values from the data sheet and 0.11 degrees a watt for the heatsink thermal resistance, well, I'm sitting right on the edge. So I don't know if it will work, but I also don't know that it won't work. One thing that makes me wonder, how is it that the biggest temperature difference will be across that tiny gap of thermal grease between the case and the heatsink? But I have no way of measuring the actual case temperature, so I think I may have to order one of the big MOSFETs and give it a try. Thank you for watching.